Hey guys, we are going to start chapter 4, unit 4 now, and we are going to start with 4.1, patterns and functions. Going to do a lot of work with functions in this chapter, or in this unit. Okay, first of all, we have some vocabulary. The domain is the set containing all the inputs, the x values, or the independent variable. Okay, so all of those words are interchangeable. They're synonyms, domain, inputs, x values, independent variables. And then the alternative to that, or the opposite of that, is the range, which is the set containing all the outputs, the y values, or the dependent variable. And again, you can use all of those words interchangeably. Range, outputs, y values, dependent variable. They all mean the same thing. Okay, so here's a little example. Our input is gallons. How many gallons we're talking about. So these are our x values. They are our independent variable. They're our domain. The output here is dollars. So we're talking about how many gallons cost how much money, or how much money for how many gallons. So these are your y values. They are the outputs, the dependent variable. They're the range. So to list your domain, you want to list it in set notation. So we're using that curly bracket, and I know they don't always look great. Mine don't either, obviously, no big deal. So your domain is your x values, your inputs, 10, 12, 13, and 17, and then close it up. Your range would be $19.99, $23.99, $25.99, and $33.98. Close it up. Domain and range, simple as that. It's your x's for your domain, your y's for your range, input and output, independent variable, dependent variable. Okay? All right, a little more vocabulary here. A relation is just a set of ordered pairs. Any set of ordered pairs, that's a relation. Okay, so example 2, 3, -7, 5, 6, 4. That's a relation. Any set of ordered pairs at all. I just randomly made up numbers. That's a relation. Some relations are special, though, and if they have a certain property, they can become or be a function. A function is a relation such that each input is paired with exactly one output. Let me say that again. A relation. Okay, so a set of ordered pairs where each input is paired with exactly one output. In other words, maybe a simpler way to think of it, your inputs are your x's, your outputs are your y's, so each x can have only one y. So let's do an example with some words first. So Mr. Farron's favorite football team, for I have no idea why, but his favorite team is Michigan. Ugh. Mrs. Fischel's favorite is Ohio State. I don't really know what Mr. Allegretto's is. I just made something up. Let's say it's Penn State. Okay, so if you look at these, each x value, each input, has only one output. Mr. Farron only likes Michigan. I only like Ohio State. Mr. Allegretto only likes Penn State. So that would be a function. Because in this relation, each x is only going to one y. Okay? So as this is written, we have a function. Now, let's say that Mr. Farron finally comes to his senses and decides he does like Ohio State as well. Now, this x value has how many y's? It has two y values. So this is no longer a function. As soon as a single x value has more than one y value, it cannot be a function. Okay? So as this one is written, not a function. Now let's say that Mr. Farron really comes to his senses and decides he doesn't like Michigan at all, which nobody should, right? Because Ohio State's the way to go. So now we have this happening. Nobody likes Michigan, which is the way it should be. So we don't even need that really in our list, right? Is this a function? Does each x have only one y? The answer is yes. It is a function. Sometimes students will say, but yeah, look, Ohio State has two different x's. But read this sentence. It doesn't say each y can only have one x. It's each x can only have one y. This x, Mr. Farron, only has one y. This x, Mrs. Fishel, only has one y. And of course, this x only has one y. So this is okay. This is a function. So keep that kind of straight in your head. Let's try an example with some numbers. Maybe. There we go. Okay. So if I just have here, 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 and here. Whoops, kind of missed that. Pointing to the 0. What do you think? Function or not a function? This is not a function. It is not a function because my x value of 9 is paired with two things. It's paired with 0 and it's paired with 3. But each x can only have a single y. So therefore, this would not be a function. What if instead of that, what if I had here, here, and here? Is this a function? Yes. Each x value has exactly one y. It's only paired with one thing. How about what do you think here? Function or not a function? This is a function. Each x value has only one y. It's okay that two x's have the same y. That's all right. It's each x has exactly one y. So this one does work. Okay, so hopefully that makes sense to you. If it doesn't, rewind, watch that again, ask questions in class, write a question off to the side, and let's make sure that we understand fully what a function is. Each x can only have one y. By the way, these little drawings that we're making, where we have our input over here and our output over here, and then arrows saying what's connected or what goes to what, that's called a mapping. So if you hear me use the word mapping, that's what they are talking about here. This is a mapping. List your inputs, list your outputs, draw arrows. All right, example, tell whether each pairing is a function and identify the domain and range. So this is a mapping. We have, let me get rid of this bottom part so we're not looking at that. We have our inputs listed, we have our outputs listed, and we have arrows drawing connecting things. So what this actually means is we have the 0.40, we have the 0.51, we have the 0.52, and we have the 0.93. Okay, so this is listed as ordered pairs. This is the version of it as a mapping. It really doesn't matter what version they give you, whether they give it to you in a chart, a table, a mapping, ordered pairs. The same definition is applying to all of it. A relation has to have, this is what I wanted to say. Each x can only have one y to be a function. Okay, so is this a function? No, it is not a function. Why not? Because this x has two separate y's. Okay, we can still list the domain though. The domain, of course, is your input, your x values, so 4, 5, and 9. And your range is your y values, your outputs, which would be 0, 1, 2, and 3. Curly brackets using set notation there. Okay, same instructions. Is this, now we're looking at it in a table, is this a function? Does each x, each input value, have exactly one output value? Maybe you don't like looking at it as a chart. Maybe you want to make it into ordered pairs. Maybe you want to make a mapping out of it. You can do that. That's fine. Let's look at it as a mapping. So here's our x's. We have 4, 5, 6, and 9. For our y's, well, we actually only have what? One y. They're all the same. They're all 10. Okay, so our mapping, 4 goes to 10, 5 goes to 10, 6 goes to 10, and 9 goes to 10. Is that a function? Yes. Each x value has only one y value. It happens to be the same exact y value, but again, that doesn't matter as long as each x has one y. Your domain, we write it in set notation, 4, 5, 6, and 9. And your range, we write in set notation. It's just one number, just a 10. Close it up. Okay, now look at this one. Is this a function? Does each input have exactly one output? Does each x have only one y? Well, you might say, yeah, because this 10 goes to that 4, this 10 goes to that 5, this 10 goes to that 6, this 10 goes to that 9. However, those are all 10s. 10s are all the same. So there's really only one element in the domain, right? That only element is a 10, but it's going to 4 different things in the range. It's going to 4, 5, 6, and 9. So that means no, this is not a function. Okay, one more. Whoops, 2 more, I guess. We're looking at them as ordered pairs now. Does each x here have only one y? 2 goes to 7, 3 goes to 8, 4 goes to 7. So all your x's are different. Each x is different in here, and it's only paired with one thing. So yes, this is a function. Your domain is 2, 3, and 4. What's your range? It's 7, 8, and 7, but we already wrote the 7 for this one, so we only need to write it once. Now the last example here. This is just the same thing flipped around, just like those charts were. Is this a function? Well, does each x only go to one y? No, because look, we have 7 as an input twice, and it has 2 different y values. So no, this is not a function. Your domain is 7 and 8. You don't need to write that 7 again. And your range is 2, 3, and 4. So this is not a function because this 7 goes to 2 and it goes to 4, but each x can only go to a single y. Okay, make a table for the function. Identify the range of the function. So here's our function. We want to make a table for it, so x and y, but they've given us our domain. Is domain x or y? It's x. So 2, 6, 10, and 12 are going to be our x values. And then to find your y's, you're going to do what? Plug in those for your x's. So y equals 1/2 times 2 plus 7, which gives you 1/2 times 2. That's 1 plus 7. Y equals 8. For 6, you would have y equals 1/2 times 6 plus 7. 1/2 times 6 is 3. Oops, I didn't need that last parenthesis. 3 plus 7 is 10. So if y is 6, or if x is 6, I'm sorry, y is 10. Okay, pause the video. You guys do the 10 and the 12. Okay, check out what you got, check out what I got, see if it's the same thing. Okay, so then the range, we made our table, identify the range. It's just your outputs, it's your y values. 8, 10, 12, and 13. There you go. Okay, write a rule for the function. Write a rule, it means write an equation. So we need to come up with something that looks like this. They're going to give us the chart. We have to come up with the equation. So kind of backwards from that problem. What you want to do is look and see what you're doing to this number each time. So what could you do to 4 to get 7? Well, the easiest thing, I think, is just to add 3. And then you want to see if that pattern continues. From 7 to 10, are you adding 3? Sure. Does it add 3 here? Yes. You also want to do that on the outputs. So from 8 to 11, what are you doing? You're actually adding 3 here too. These don't always have to be the same, like what's going on here doesn't have to be the same here. It's okay if it's not. But going from one number to the next in the order this way, that should be the same. If it's not, you want to look for a different pattern. Okay, so we have this. Now, start out with y equals, because we want to end up getting our output. We're going to do something to our x, and we're going to get our y. Once you figure out what's going on the inputs and on the outputs, what you want to do is take your output and divide by the input. Whatever's happening on the output difference, and divide it by the input here. So that would be on this one, +3 is happening for my outputs, and +3 is happening for my inputs. Well, that's really just 1. That's going to get multiplied by your x. Okay? Now the last thing to do is to figure out, do I need to add or subtract some number here? So take one of your coordinate pairs, right, because this is an x and a y, and plug it in. We'd have 8 equals 1 times 4 plus something. Well, this is 8 equals 4 plus something. What would that something have to be? Well, if you subtract 4 on both sides, solving for this question mark, 4 equals your question mark. So that means your rule is that you have 1x plus 4. Check it with any of the other ones. 7 is your x. 1 times 7 is 7. Add 4, you get 11. 1 times 10 is 10. Add 4, you get 14. 1 times 13 is 13. Plus 4, you get 17. Let's try another one. Okay, so again, go down your outputs. Figure out what you're doing. Is it the same thing each time? Well, from 512 to 509, I could be subtracting 3. That works here, and it works here as well. So good, same thing each time. Over here, what are we doing? We're adding 1 each time. Okay? Then you want to take your output difference over your input difference. Okay, so we have y equals something times x plus or minus some other number. Well, the thing that goes here is your output over your input. Okay, same thing we did up there. That's, of course, just negative 3x. And then we need to figure out, should we be adding or subtracting some other number? Okay, do I need to add or subtract something back here? Take one of your ordered pairs and plug in. Y equals 512, negative 3 times 0 plus something. Well, this is 512 equals 0 plus something. Well, that's just 512 equals our something. So our equation has to be y equals negative 3x plus 512. Okay? All right, here are 2 problems for you to try. Pause the video and give those a shot. Okay, number 1 is a function because each x only goes to one y. It does not matter that the 1 and the 6 share a y. It just has to be that each x only has one y. Your domain is 1, 0, and 6, and your range is 3 and 5. Okay, to find the rule for this table, here you're adding 1. Here you're adding 2, so this is different than the other example, so you might have gotten tripped up a little bit. You're not doing the same thing each time. Let's look at this side. You are adding 5. Here you're adding 10. Okay, so again, something different. However, look at what your output difference is over your input difference. Your first one is 5 over 1, which is, of course, 5. Your second output difference over your second input difference is 10 over 2. Well, that's also 5. So it's okay if you're doing something different here, as long as the output difference over the input difference is the same. Once you have that, of course, you're going to multiply that by the x, and then you need to decide if you should add or subtract something and what that number should be. The way you figure that out, plug in one of your ordered pairs. I'm just going to pick the top one. Negative 3 equals 5 times 0 plus something. That's negative 3 equals 0 plus something, which means our something is negative 3. So your rule is y equals 5x plus a negative 3, which is y equals 5x minus 3. Check that with one of your other ordered pairs. I'm going to check it with the 1, 2. So if I plug 1 in, 5 times 1 is 5, minus 3, sure enough, that gives me 2, so that one worked. 5 times 3 is 15, minus 3 is 12, so that one works as well. Okay? So again, it's okay if these things are different as long as this part, 5 over 1, 10 over 2, as long as that comes out to be the same number. Put that number next to the x and then figure out what you should add or subtract.